introduction, I was asked last week, and I'm not making this up, by an eminence in the field for me, of all people, to tell him who the leaders in academic medicine that were paving the way for personalized or precision medicine. And I said, listen, I really can't answer that question. It's like asking a parent who among his children he likes best. But I also said Intermountain Healthcare distinguishes itself because of its leadership and its willingness to commit all of its resources in its entire institution to the effort to promote personalized medicine, including studying its effects, without which I don't think the field can progress as fast as otherwise. And that leadership is due to Lincoln Nadauld. And I want to turn the podium over to Lincoln, who directs the Precision Medicine Initiative at Intermountain Precision Healthcare, to offer a few welcoming remarks. So, Lincoln.
Well, thank you, Ed, and what a venue. Can everyone believe this? I think a round of applause to the PMC team. When I was talking with Ed and we were wondering where to have this, I said, well, let's just do someplace that looks like your front room. And that's how we ended up here. I guess this is the closest match. It really, honestly, is a thrill to look out and see everyone. On behalf of my colleagues and coworkers at Intermountain Healthcare and Intermountain Precision Genomics, I would just like to say thank you. Thank you to the Personalized Medicine Coalition. Thank you to all of our friends from the many institutions and companies across the country who are here tonight. As everyone was walking in, my team and I were sitting here saying, oh, the guests are arriving, the guests are arriving. And it was really exciting. The other thought I keep having when I look around the room is, this is a room of friends. I really feel like we're all in this field together, and while we are playing different roles, I don't feel like they're competitive roles. I feel like they are complementary and synergistic roles. And I don't necessarily always feel that way at various meetings, but I do here, and it's really unique, and I'm grateful for that. I wanted to just share, as part of my brief comments, a couple of numbers that came up today during the conference. And these, I think, numbers are interesting for a lot of reasons. So, the first number, 14 new genetic tests come to the market daily. That's every day. Think about the lift to just get one genetic test to market. Consumers have ordered 12 million over-the-counter genetic tests to date. So 12 million, that's another startling number. 132 drugs with biomarkers in their FDA label are available on the market. That's a startling number. And the last one I'll share is 14,000 different genetic tests are currently offered in the market. So those are some numbers to know, and I think they say something about the field of precision medicine. And I wanted to just take us on a brief journey in precision medicine, and I wanted to use oncology as kind of an example, knowing and acknowledging that precision medicine, of course, spans all fields of medicine. But I'll just use oncology as one example to demonstrate the growth that has happened in this space. In 1971, everyone knows that year, right? 1971, Congress passed the National Cancer Act. This was really the result of Mary Lasker and her late husband Albert F. Lasker and their efforts to spur the National Cancer Institute and Congress into funding the National Cancer Act. And that's what we have now known as the Declaration of War on Cancer. So that was in 1971. A few years later, Michael Bishop and Harold Varmus at UCSF discovered that it was really normal cellular genes that become mutated or inactivated that cause cancer. And then they subsequently were awarded the Nobel Prize in Physiology or Medicine in 1989 for that discovery. About that same time, in the mid-80s, what's his name? Oh yeah, Denny Slayman. Oh yeah, that guy. Denny Slayman. And his colleagues at UCLA and others at the University of Texas, and actually at the NIH, discovered that HER2 can promote the growth of genes all by itself if you overexpress or amplify it. That subsequently led to the approval of really the first targeted therapy that had a gene in its label in trastuzumab after collaborating with Genentech. That approval was granted in 1999 for metastatic patients and then subsequently was approved for adjuvant treatment in 2006. In the year 2000, the Human Genome Project was completed, and the next year, imatinib was approved for BCR-ABL positive CML patients. Okay, so that, just a little journey there. 1971, the National Cancer Act, and then the discovery that genes and abnormal genes can cause cancer. And now we start getting some of the first targeted therapies coming out in the late 90s and early 2000s. And that moves us all the way forward to today. And I want to share a couple of interesting facts just about 2017. Okay, so just last year, 5 things. Number 1, 3 gene therapies were approved in 2017 alone. Number 2, a tissue agnostic indication for a cancer therapy was approved. That's the first time that has ever happened. So it doesn't matter what kind of cancer you have. You can get this drug if you have a certain set of biomarkers. Number 3, a direct-to-consumer genetic test was approved by the FDA. That's actually kind of startling. Number 4, a personalized medicine biosimilar was approved. So now we're approving biosimilars. And number 5, a test using next-generation sequencing was simultaneously approved by both the FDA and CMS. Then the final thing I'll add about 2017, 16 new personalized therapies were approved in 2017 alone. So starting back, if you go back to 1971 and some basic scientific discoveries about the role of genes in cancer and the completion of the Human Genome Project and the first approval of certain targeted therapies, now in 2017 and now today in 2018, an avalanche really of findings and therapies and opportunities for patients. So I now want to share 5 learnings and then 4 points of vision. So the first of 5 learnings is that precision medicine works. Precision medicine works. The second learning is close. Precision medicine does not work for everyone. Yet, that's the rejoinder that I would add. Yet, no one ever claimed that precision medicine would work for everyone from the first day. That was never the belief or intent. On the other hand, precision medicine is clearly making a difference for increasingly large segments of our patients across medical disciplines, and it's sufficiently effective that it is not going away. Rather, it continues to grow, and what we're doing is figuring out how best to apply it and which patient populations need it and when to give it and when to implement it. So precision medicine works, not yet for everyone. That's coming. The third learning, precision medicine can be and should be applied across all disciplines of medicine. Oncology, cardiovascular medicine, pediatrics, women and newborns, neurosciences, musculoskeletal diseases, surgical services, infectious diseases, etc. I cannot think of a discipline in medicine that would not benefit or cannot benefit from the approach of precision medicine. The fourth learning, not all precision medicine uses involve genomics. There are lots of examples of that. We can talk about it. And the fifth, and I think maybe the most important, we must measure outcomes. We do a disservice to patients, we do a disservice to the field, we do a disservice to our institutions when we implement precision medicine and we don't have the discipline to measure the impact on patients. Not only the impact on their outcomes, their survival and other measures, but on the economic impact. We have to include those measures. In an era of static financial resources in healthcare, we have to have sufficient discipline and maturity that we are willing to measure those impacts, or else we're going to limit the scope with which this can be applied to patients. Now, a vision, and I'll conclude with this, a vision, 4 points for patients and for precision medicine. The first is, let's sequence everyone. Sequence everyone. Do I need to add anything to that? Actually, I want to add a little color there. One of our goals, and I'm not going to just present this vision and say everyone else should do this, I'm going to share what we're doing about it. Sequence everyone. In Q1 of 2019, we will be sequencing all newly diagnosed cancer patients of any stage and of any tumor type that comes to our institution, meaning germline testing. There are far too many patients that have inherited pathogenic variants that confer a risk for them to develop that cancer, and we need to know who they are. We live in an era where it's cheap enough and it's fast enough and we can afford to do this and we understand enough that we can do it in a responsible way. And genetic cancers that we don't know about and show up as late-stage disease are a public health crisis, and we should attack that because we have the means to. So, sequence everyone. That's part of our vision, and I think that's a vision for all of precision medicine. Number 2, precision medicine across all medical disciplines. We all have our favorite, we all were raised somewhere, but let's get it in everywhere. So we're trying to take this tack to Intermountain Healthcare. As an example, we have rolled out pharmacogenetic testing in both our mental health clinical program and our primary care clinical programs. And any patient with a new diagnosis of depression or anxiety, any patient who has not responded to initial treatment for depression or anxiety, or any time a physician simply wants to order it, we're implementing that kind of testing and making it available for patients across all 22 hospitals and 180 physician clinics in our system. Similarly, we are launching germline genetic testing in our primary care clinics, and we are going to make our primary care physicians experts in genetics. We're going to rely on them to help us follow these patients up. We're going to support them with a lot of genetic counselors, and we're going to do this in a partnered fashion, but we think that that's where we're going to really make an impact, is in the primary care setting. So precision medicine across all medical disciplines. I could go on about our plans to roll out whole genome sequencing in the NICUs and other places where we're going to be implementing genomics and precision medicine, but the point is across medical disciplines. Number 3, artificial intelligence in precision medicine. So one thing that we really believe in is the ability to look at large data sets and make discoveries. As an example, one project that we recently completed was polling patients, no genomics done on any of these patients. This is my previous point about not all precision medicine is genomics. We can look at diabetic patients, and using artificial intelligence, we can predict and provide a top 100 list ranked most likely to least likely of patients that we think are going to be admitted to the hospital in the next 30 days. So we actually are now generating lists of patients that we think are at risk for this to happen. We're getting them into our high-risk internal medicine clinics and intervening before they wind up in the hospital. So AI and precision medicine. And the 4th and last point of vision for precision medicine is value-based implementation. We, I think, run the risk of being addicted to fee-for-service models, where we want to drive volumes through our labs, we want to run more and more tests, and that is also a disservice to patients and to the healthcare system. If we can launch this in a value-based fashion, where we're saving money for entire populations by implementing precision medicine, we will again expand the scope and the breadth and the depth to which we implement precision medicine. And with that, the final comment that I'll make is that I firmly believe our best days are ahead. The best days for patients, the best days for scientists, the best days for practitioners are all ahead of us, and that's good news. With that, thank you, and have a wonderful evening.